let's apply the same strategy for part B. This time we have an alternating series. And as a side note, you can also use alternating series test to determine its convergency. But why don't we use the ratio test for that purpose? So an in this case is -1 to the n plus 1, n plus 2, n plus, sorry, this is going to be n, right, times n plus 1. Okay, so I'm going to look at the ratio an plus 1 over an, but I'll take the absolute value as well. I got to take the absolute value here, and it's important because this part here is alternating, so that switches its sign from one term to another. So that is going to make the whole ratio to be negative. That's why we take the absolute value here. So for that reason, I don't need to worry about the alternating part, because at the end of the day, I'm gonna take the absolute value. But let me just keep everything in order so that you will see why I don't care about that term anymore. So for an plus 1, I'm going to replace n by n plus 1 in the description of an. So this becomes n plus 2. This becomes n plus 3. This becomes n plus 1. And this becomes n plus 2. So in the next step, I should divide this by an, right? But instead of doing that, well, an is right here. So I'm going to do everything in one step. So I'm going to flip an over. So it's going to be n plus 1, minus 1 to the n plus 1, n plus 2. Okay? I just wrote the flipped over version of an so that we save space here. Okay? So here is what's going on. All right, I have n plus 1 here, canceling this n plus 1. Okay? This minus 1 to the n plus 1 cancels this minus 1 to the n plus 2, and then we are having only left over -1. Okay? And this whole expression is reduced to, let me just write everything carefully, minus 1 n plus 3, okay, n plus 2, n plus 2 squared, all right. So minus 1, as I said, is not important. I'm going to get rid of the absolute value sign because n is positive, n plus 3 positive, n plus 2 squared positive. Okay. So now in the next step, what I'm going to do is to pass the limit. Okay. So here, why don't we expand the top and the bottom? N squared plus 3n, n squared plus 4n plus 4. When you pass the limit, here it's going to be infinity over infinity, so why don't we use the L'Hopital's rule? Okay. Well, it's 2n plus 3 at the top. You take the derivative of the top, you take the derivative of the bottom. And obviously this is still infinity over infinity, so you give another shot of L'Hopital's rule. So you have 2 at the top, taking the derivative of the top, taking the derivative of the bottom. The limit is 1. Oops. This is one of the unfortunate case number 3. When the limit is 1, the ratio test is inconclusive. Okay? So that's bad news, right? The test is inconclusive. Okay, how do we handle this infinite series then? Well, as I said, you can always use the alternating series test to get the convergence or divergency. So at this moment, you can pause the video and you can use the alternating series test, and I can tell you that this series converges conditionally. So this is a good practice moment for you because we learned alternating series before. So why don't you apply the alternating series test to this series as a practice to verify that the series converges conditionally. But in this case, unfortunately, the ratio test is inconclusive because the limit spits out 1. So you have to go back to the alternating series test.